First, let's look here at the step-by-step process of fine-tuning a pre-trained foundation model. Conceptually, fine-tuning is a form of transfer learning. So we are like taking a general purpose model which has already learned a vast amount of like world knowledge and adapting it to a specific like downstream how to say like a downstream task using a smaller labeled data set. And so the process generally involves like five key steps, right? So the select pre-trained model, data preparation, model configuration, training, and then evaluation. And in the pre-trained model, uh, first we choose a model architecture like Llama or BERT that fits our task constraints and like resource availability. And then in data preparation, we collect and clean our domain specific data, formatting it into the input output structure the model expects, such as like instruction response pairs. And then in model configuration, we then load the pre-trained weights, right? So to make training efficient, we might use like a parameter efficient fine tuning math. Yeah, because like hold on, let me see. Do we have? Yeah, yeah. Like we might use like parameter efficient fine tuning methods like LoRa or QLoRa, which like freeze the main weights and only like train a small adapter layer. Um, so I spoke about what pre-trained data configuration training. So in training, we run. Did I already not talk about training? Yeah, but in training, we essentially run the optimization process using gradient descent. Importantly, we use a much lower learning rate than was used during pre-training to avoid like catastrophic forgetting, I'd say, where the model loses its original knowledge. And then in evaluation, we then pass performance on a held out test set using metrics relevant to the specific task. Um, so start like how do I say like standard fine tuning makes like it makes a model. Let me actually even hold this like this. Yeah, like it makes a model like good at a task. You know, yeah, it makes a model like good at a task, but it doesn't like always make it safe or helpful. And that is where reinforcement learning from human feedback comes in. Um, so like reinforcement learning human feedback is like the alignment stage used after supervised fine tuning. And so its goal is to like align the large language model's behavior with human values, like specifically to ensure it is helpful, harmless, and like honest, right? And so like this is critical because it mitigates like risk like bias, hallucinations, toxic outputs. And so like yeah. And so the process just like has like this process is like it has like three main like components, right? It collects human preference, train like a reward model, and then it optimizes the large language model. And in the collection of the human preference data, we give the model a prompt and generate several different responses. I'd say human annotators then rank these responses from like best to from like best to worst. And then in training a reward model, like we use that ranked data to train a separate reward model, and so like this model learns to predict um, it learns to predict a numerical score representing how much a human would like would like a given response per se, right? And to optimize a large language model, we use a reinforcement learning algorithm, like typically like proximal policy optimization. So the large language model generates text. The reward model it gives it a score, and the proximal policy optimization updates the large language model's weights to maximize that score over time. Um, and so yeah, if we have to discuss like data preparation, this is often, like I'd say, this is often like the most labor intensive part of the pipeline. Um, to prepare for like data for fine tuning, we go through like collection and curation together, like common, not common, sorry, together like domain specific text, right? Like followed by like cleaning to remove errors or duplicates, and then we then like handle formatting and tokenization, like converting like raw text into like specific prompt completion structures, that the model requires, right? And then finally splitting the data into like train, validation, and like test sets.